Hello, I am David Cordall from Centenary College of Louisiana, and today I'm going to talk about historical flirtations with the physics of the paranormal. Now, the topic of this session is the history of underrepresented groups in physics. My talk has the goal of bringing our attention to a group that is underrepresented not in physics nor in the world at large, but in our discussions of physics and its history. The group I'm referring to is that of believers in the paranormal, in those areas of human experience that are, at the moment, considered by many scientists to be unscientific almost by definition. By briefly skimming the history of science and magic, and by looking at two cases, one from the late 19th century and another from the late 20th, we can ask the question, what possibilities might physics miss out on by ignoring the work of enchanted physicists? The fascinating prehistory of science and the paranormal is that, on the one hand, science and so-called magic went hand in hand in the long development of science, and, on the other hand, once science and magic came to be seen as opposed, this development was led less by empirical than by philosophical trends. Modern investigators into esoteric traditions like alchemy, by physicists including Lawrence M. Principe, have sworn there was significant empirical content in such traditions, and modern investigators in the decline of such practices show the way that philosophers rather than scientists led to this decline, as self-styled scientists were less willing than philosophers to jettison empirical content. Questions regarding magic and the paranormal have been somewhat unwelcome within science since the Enlightenment, but Jason Josephson Storm has argued that disenchantment as a post-Enlightenment historical process of demystification is itself a sort of meta-myth, as magical beliefs have never been purged from the wider culture. If we use the term paranormal as a blanket term to include such disparate claims as the reality of extrasensory perception, ghosts, and UFOs, Josephson Storm estimates that about 3/4 of Americans hold at least one paranormal belief. It should not surprise us if some of these people are, or, more to the point, for educators, might become physicists. The two cases I'm interested to highlight today are modern instances where paranormal belief had an appreciable contribution to what has since become accepted in our field. The first is that of William Crookes and the Society for Psychical Research. Crookes was a master spectroscopist important for his discoveries in rarefied gases. In physics education, students may still hear his name when we refer to the Crookes tube, an early version of the cathode ray tube which helped to establish the particle character of the electron, and the Crookes radiometer, where the electron spinner's spinning when light hits it seems like one thing, but is more likely something else. Crookes had a long-standing interest in paranormal phenomena, and when the Society for Psychical Research began its attempts in engaging these subjects with scientific skepticism, he became a key ally. In fact, Crookes commented that his more traditional work was carried out in part to give him the credibility to make his less conventional claims. In the book Physics and Psychics, Richard Noakes provides valuable context for the intersection of spiritualism and science. In this book, Lord Kelvin is quoted in a letter to Lord Rayleigh, another member of the Society for Psychical Research, that Crookes' discoveries all arose from his investigating mesmeric attraction. The claims of Crookes are still widely available online and are periodically rediscovered by paranormal enthusiasts. The sort of phenomena he reported are the stuff of horror fiction, with mediums causing objects to levitate without touching them, and materializing bodies of spirits. When Crookes took pictures of these materialized bodies, as in the photo shown here, he understandably was met by skepticism from scientists, the general public, and critics of spiritualism alike. Though Crookes suffered significant reputational costs for his paranormal adventures, he continued to believe in the veracity of his findings until his death. Physics and Psychics tallies the members of the Society for Psychical Research with a physics background, and it's intriguing that most physicists with such interests were experimentalists out to observe novel effects, rather than theorists out to predict or explain. In the end, after the advent of relativity and quantum theory, Crookes' style of theorizing came to seem old-fashioned, as he continued to attach his ideas to a revised ether theory. Hence, younger physicists opted to investigate the other vast mysteries that theoretical innovations had opened up. Flash forward to a second episode. The second episode I'll highlight here occurred as the rapid mid-20th century developments in physics began to slow and get weird, a strain that David Kaiser has ably described in How the Hippies Saved Physics. As Kaiser described it, in the 1970s, cuts in physics funding in the United States left young physicists with more time than money, leaving time for those members of the fundamental physics group in Berkeley to discuss, among other things, questions relating to Bell's theorem. So when they were not discussing remote viewing, ESP, or psi, one of the questions that interested group members was that of whether quantum theory meant that faster-than-light signaling might be possible. Kaiser discusses the various strains of esoteric speculation that surrounded this milieu, but these faster-than-light schemes had real payoffs in a roundabout way. The physicist Nick Herbert invented a number of schemes that promised superluminal signaling. Here I've sketched his flash system, the first laser-amplified superluminal hookup. The controversial piece of this setup, which was not obvious to many readers at the time, was the amplifier that could perfectly reproduce a general quantum state. The linearity of quantum theory, it turns out, makes this untenable, with a result that is now known as the no-cloning theorem. The surprise here is that this group of fringe occultists influenced ideas that have since become part of the physics mainstream. Responses to ideas about Bell's theorem have allowed us to understand how correlations can be non-local while still not allowing information to be transferred, and rebuttals to superluminal information schemes spurred the developments in quantum theory and its applications, like quantum cryptography. Now, some might point out that paranormal interests aren't a necessary precondition for any of those discoveries. Yet, it's interesting to realize that there was a definite closing of the ranks with the creation of organizations like CSICOP, the Committee of Scientific Investigation of Claims of the Paranormal, which today has become the CSI, the Committee for Skeptical Inquiry, whose members include many prominent physicists. As we can see in the quote from Martin Gardner and John Wheeler, there was an effort to cordon off the genuine mysteries of physics from the imposter mysteries of the paranormal, leaving paranormalists like George P. Hansen to allege that CSICOP is itself a political, not a scientific organization. Of course, all of this takes us far beyond what can be discussed in a short talk. But, as public interest in topics like UFO peaks, it will fall to science educators to field questions concerning such topics to their students. There is a rich historical literature regarding the connections between magic and science, and historically scientists have not always been of one mind about such issues. The question of what is in or out of bounds for scientific studies is a negotiation, and it seems to me that we should, as physics educators, be willing to admit that the boundaries of physics are not sharply drawn, and that there can be spooky areas at the edges. Who knows? It might benefit not only potential physicists with a side interest in the paranormal, but the development of physics itself. Okay, so thank you for your time.